His main research interests are in the neurosciences, neurobiology, neurotoxicology, neurodevelopment, and glial function associated with neurological conditions and neurodegeneration. He has published more than 70 research papers, mentored over 30 postgraduate students, and have given more than 150 communications in scientific meetings in several countries. He is an editorial board member of scientific journal Antioxidants, guest editor of Dietary Polyphenols and Neuroprotection, associate editor of Frontiers in Cellular Neurosciences and Non-Neuronal Cells. Professor Rui, your presence here today signifies a remarkable opportunity for our students and faculty to benefit from your wealth of knowledge and experience. With these words, I would like to invite Professor Rui Silva to kindly share his presentation on the topic macro and micro alterations during neurodegeneration and aging. But before we start the presentation, so please, I would like to just bring there is another scientific eminence, Professor B.N. Malik. He is a professor of neurobiology and currently he is heading the department. And he has been superannuated from JNU, Jawaharlal Nehru University, New Delhi. He has a vast experience of over 40 years in sleep neurobiology, and he has received several awards, which includes J.C. Bose Fellow and Bhattagar Award. So, would you like to please come here? Yeah. Or you can just sit here as you feel. Yeah. Nice meeting. So, yeah.
Okay, first I would like to thank these kind words from Dr. Sharu Gupta, and most of all, thank her for this kind invitation to be here. It's a pleasure to be in India. It's my first time. I'm enjoying this experience a lot. And to you students, I hope you understand my English and that you will be able to understand also what I'm going to tell you about aging and a little bit about. We have a mouse? Not there. Okay. Thank you. Okay, first of all, I come from Lisbon with these images. I don't know if you know where Lisbon is. Anyone knows? Which country is this? Portugal, of course. So, Portugal, this is the view from top of Lisbon to Tagus River. That is the river that is along all the margin of Lisbon. No, it's okay. The river is there on the top. It's the river, and this is one of our main streets. So Portugal is quite an open country. You see, I don't have the pointer, sorry. So I'll try to do it like this, if this works. Okay. This small country here is Portugal, the close to Spain. So in one side we have Spain, on the other side, so we can't escape much, or just we go to swim. So it's not a too big country. It's around 11 million people, half of the population, something like that. So if you start to move there, we will be without any space. But it's very good to travel there because we have basically everything. We have the beach, we have nice cities, we have fun in the evening for the students, and our university is the biggest university in Portugal, is the University of Lisbon. So we have several courses from humanistic areas to biological areas to medicine, pharmacy, physics, chemistry, all the knowledge areas. So you can always try to travel there to go to classes and to teach and I will, in particular, I'm in the process of trying to establish some Erasmus scholarships that you already have with Slovenia, not yet with Portugal, but I will try to do that for you to be able to go, so to study there for a period of 1 to 3 months. But the process we will try to start the process as soon as I go back. Okay? So regarding Lisbon, this is my university, and now let's hope this works.
Dear Peter, hope you are okay. I've been studying in Lisbon for 2 months now. It is such a beautiful place. The light, the monuments. This city just breathes culture and history. Everywhere you look, you always find something to inspire you. Lisbon is also a very safe, creative and cosmopolitan city, a unique blend of past, present and future. People are super friendly and there's always something for you to do. I'm loving university. My teachers are brilliant and it offers excellent learning facilities. I know you're planning to study abroad as well. I mean, what are you waiting for? Hope to hear from you soon. Miss you, Carol.
I have to hide now this. This one, right? Okay. So now going back to what I will tell you, it's about first about neurodegenerative diseases and the relation. Then I will move to aging and aging processes, not only in the brain but also in all our body. Because I'm already old, you are in the way of getting old, so I hope you know what happens in our bodies when we age. So these are the main topics that I was already telling you. I'll talk about a little bit about neurodegeneration, but you are neuroscience students, right? So you know everything about this better than me, probably. We'll see. And then I will talk about theories of aging and aging on the several levels of our systems. So you know that neurodegenerative diseases are due to the cell death of which cells? Neurons and also glia. So that's what the characteristic of neurodegenerative diseases. Neurons die in our brain, and in most of the cases, that leads to a condition that it's called dementia, right? So this here you see mostly the biggest diseases related with dementia, which is Alzheimer, Parkinson's disease, vascular dementia, frontotemporal dementia, and then the movement disorders, ILS, and so on, and Dixon disease. So these are all neurodegenerative diseases that occur in our brain due to the loss of neurons. So this is too soon. So I'm going to ask you on this presentation. Fine. So how long do you think that will take for one person in the world to get dementia? Now we are just counting time. How long will it take in this moment for one person to be diagnosed with dementia? Do you have any idea? Anyone? Do you think 1 hour? Each hour, one person will develop dementia? Less? Who votes for less? Raise the arms. Who votes for more? Raise the arms. Mm-hmm. It seems it's more than 1 hour, right? So don't be surprised because it's every 4 seconds. Every 4 seconds, a person in the world is diagnosed with dementia. So And this has a huge economic impact, because if you ever had the contact with a person with dementia, they are unable to take care of themselves. So they need the help of the family, of the healthcare providers, someone to take care of them, because they can't. And that's a huge economic impact. And just in 2019, in the States, because that's where we have most of these statistics, they were estimating to cost $1.3 billion in 1 year. So in the world, more or less 55 million people have dementia currently. And this number is the current number, because remember that these people die. So this is a status number that is increasing a long time. Unfortunately for the girls and the women, 65 of the cases are feminine based, more females than males. And dementia is the 7th biggest cause of death in the world, right? So these are some projections. On the left, you see the age prevalence of the dementia according to sex. So the red, pink is the females, the blue obviously are the males. And on the right, you see the forecast for increasing number of cases in dementia along the years. So you see below the time scale, right? And you see then on the left axis the number of cases in millions. So as you see, it's increasing. Okay, so what is the biggest problem to take care of, to treat and to prevent dementia? Do you know what is the biggest problem? It's that when the symptoms appear, when people go to doctor telling that I don't remember this, or I can't remember anything, I don't know the name of my cat, people then go to doctor. But at that point, so if neurons don't regenerate, when we go to the doctor, our neurons are already dead. And it's quite difficult then to go back to the normal situation. So that's one of the biggest problems of treating dementia. Okay? So the diagnosis is late and there is still no cure. So we can't go back. The treatments, now the more promising treatments that are being studied are basically to stop neurodegeneration and not to evolve further. Okay, but we are not still at the moment able to republish the neurons in our brains. That's a very complex. There are already possibilities, but to put a neuron back to the brain is quite difficult, okay, as you can understand. So in the case of Alzheimer, there are two basic signs, histological signs. Do you know what is histology? The study of the tissues, right? So the two hallmarks of Alzheimer, and we still don't know if this is the cause or just the consequence of Alzheimer, but even so, what you see in the brain of the patients is two main things. These deposits, here, can you see the mouse there? These extracellular deposits of amyloid plaques, it's deposits of beta amyloid peptide, and inside the cells you see here these purple aggregates. It's the aggregates of what we call neurofibrillary tangles, and this is what you see. This is the normal neuron, and this is a diseased neuron with Alzheimer's disease. So these two are the main hallmarks of Alzheimer. Of course, there are several other things. There are loss of synaptics. There are no loss of astrocytes. There is overactivation of microglia, etc. Okay. And so what is that beta amyloid? Beta amyloid is actually a normal protein. It's from APP protein, which is normally neuroprotective because it's implicated in the homeostasis of calcium in your brain. But in some conditions, that protein gets dysfunctional and it gets cleaved by some enzymes. And this part, this yellow part that is abnormally cleaved, goes out of the cell and produces beta amyloid plaques, those aggregates that we see, right? In the case of tau, tau is also a normal protein in our cells. It's a protein that stabilizes microtubules. Do you know what microtubules are? Cytoskeleton? Perfect. So tau stabilizes the microtubules in the cytoskeleton of the axons, which is very important for axon moving along for the movement of substances inside the neuron. But in some circumstances, this tau gets over-phosphorylated and then it disintegrates like this. It forms these aggregates inside the cells, and this is those neurofibrillary tangles that we see in the neurons. Okay? Right? And then when we look at the sections of the brain, this is a normal section of the brain. You see just the neuron, the astrocytes and the glial cells. We can't distinguish them that well in this case, but there is nothing, no deposits. And here you see the comparison of the size of a normal brain, healthy individual, with the one with advanced Alzheimer's disease. As you see, the cortex almost disappears. There is increase of the spaces of the ventricular spaces of the brain. There is almost disappearance of this area here, which is very important. It's the hippocampus. Okay, here. Here it's almost absent. And when you see these inclusions here outside and inside the cells. This is a beta amyloid plaque. This is neurofibrillary tangles, several samples of the same thing. And in the case of Parkinson's, what we see is the accumulation of these aggregates inside the neurons, which are called what? Very well, Lewis bodies. And this is an aggregation of another protein. Oops, sorry, this went too far. Okay. So this Parkinson-Lewis bodies is beta-synuclein aggregates, which is also abnormal, and this alpha-synuclein is normally involved in the release of neurotransmitters in the neurons, normal function. So all these proteins that are then misfolded are normal proteins that somehow lose that function. So now I have a question also for you. So this is all neurodegenerative diseases, right? So do you think that in aging process, it's normal to have neurodegenerative diseases? Yes or no? So everybody that gets old develops neurodegenerative diseases? The probability might increase, but it's not normal. So neurodegenerative diseases are related with aging, but it's not a normal part of aging. Many people get old without developing neurodegenerative diseases, okay? However, there are several other factors related with brain aging that not necessarily lead to neurodegeneration or to dementia, okay? And there are basically three types of causes that affect our brain during the aging process. And there are 9 indicators that are distributed in those 3 classes that you can see there. Primary, that cause the injury. Antagonistic, that basically lower the defenses of the brain. And integrative, which then is the consequence of accumulation of both. So now I want you to turn to your colleagues, two or three by three, and you are going, each of you of these groups, you'll have 2 minutes to find me one of these 9 causes. Understood? Right? Do you know what I'm asking you? I want you to discuss among yourselves. You 3, you 2, you 3 there, you 3 there, you 3 there. You have to work now. Sorry, you have 2 minutes to find one cause, and then I will ask randomly 1 or 2 or 3 groups which cause did you find. Is that okay? one of them, of these 9, any that you can imagine. Okay, I'm going to start to count the time. Go. Go on, you have to work now. Don't be sleeping on your back. And I normally ask more to the ones of the bottom because those are the ones that sleep the most. So be ready. Work. Charu. Charu. No. 15, 20 minutes. 50 seconds. So be fast. Think. Think, guys. You are neuroscientists or you want to be neuroscientists. You have to think. Okay. Time's up. So let's start with that group there. You, what? Give me one of indicator of brain aging. One cause or something that can happen in our brain during age. You? There? Do you remember of something? Cognitive decline. Epigenetics. Epigenetics, it's better. Cognitive decline is a consequence. Epigenetic modifications is a cause. Perfect. What about you there on top? Anyone? You were still sleeping. And you here on the front?
resulted in which has resulted in loss of some brain tissue and
That is a cause of neurological disability, but it's not a normal cause of aging.
okay.
Ah, it works. Great. No, I know. I have one like this, exactly the same. It's okay. It's working. But it's working here. No. Okay. Okay, guys. So these are the real factors. Okay. So decreased DNA repair, of course, right? Accumulation of ROS. What no one thought about reactive oxygen species. That's nowadays talked a lot, even yesterday. So the lysosomal and proteasomal degradation of proteins that are normal. So as you know, each protein has a lifespan, and in the end, they have to be degraded and reused. And if these mechanisms don't work, we start to accumulate abnormal proteins. And cellular senescence. Cellular senescence is the loss of ability to work as a functional cell, let's say. And also one thing that is also now talked too much is the telomere shortening. Telomere are chains that protect our chromosomes, and they get shorter and shorter with the aging. Okay, and they protect the chromosomes from damage, epigenetic damage, for example. Okay, so these are the primary, these are the agonistics. So as a result, we have worse mitochondrial dysfunction. The calcium homeostasis is dysregulated in aging, and we have the neurogenesis doesn't exist anymore, so we don't produce new neurons. And then as a result, we have a deregulated, oh, there is something here on foot. What is this? I can't get rid of that. Okay, we have deregulated energy metabolism. That's the consequence of the accumulation of these 9 main factors that lead to brain aging. Okay? So, and that's what happens in our brains with age, in the aged people. So here is a normal brain, and there you see, if we think about the images before of Alzheimer's, you also see some reduction of brain mass, but there are not that much loss of neurons. The neurons are smaller, they lose a little bit of water. The spaces are a little bit bigger, but it's nothing to do with an Alzheimer's disease patient. It's different. The morphology of the brain, it's different. There is a atrophy of the brain, progressive, 2 to 5% each year after 70. But there is not that much loss of neurons or loss of cells. But as a result, the brain shrinks a little bit, and this volume changes, let's say. And then what we see in the small changes, in the micro changes, the myelination of neurons starts to be compromised. Do you know what is myelin? Okay. So the activity of the glial cells can increase, sometimes not to healthy activity. And we can even so see some sparse aggregates or some sparse deposits of A beta or tau protein, but not forming the I beta plaques like in Alzheimer. Okay? And we also see these brown deposits inside the cells, which is lipofuscin deposits, is increased, and lipofuscin is a waste product from cell metabolism, let's say. And of course, it accumulates with the age of the cell. This is some images of alterations that occur in the brain at aging, some atrophies here, okay? Some lacunes in the brain that you can see here. You also see some white matter damage, periventricular white matter damage here. Here you see lesions on the white matter. Here you see some lacuna, some small dots, some spaces that can open in the white matter because some cells also are lost. And here some small hemorrhage inside the brain. All of this in theory can occur in the brain without being detected as a symptoms. Okay, now about why do we age? What are the theories that are behind aging? What is happening in our bodies? So there are 2 main theories. One is called clonal senescence, and it's a theory that tells that our aging is determined by our chromosomes. We have a biological clock, and it's like that. There is nothing to do, and this biological clock, it's not the same for everybody. The consequences are similar, and basically what we see is that the replication, so the replacement of old cells by new cells that you do very well and I don't do very well already, it reduces with the age. So you see the replication ability of fetal cells, of young adult cells, your case, and early adult cells, elderly adult cells, sorry, which will be, it's starting to be my case. Okay, so as you see, are replaced with a much lower pace. So there are some factors that are also involved in this genetic senescence, in this clonal senescence. In all of them, both of theories are also pointing to the telomerase reaction. So the activity of the telomerase enzyme cutting those telomeres. If we could reduce that and protect our neurons, maybe we would live longer. Okay? And of course, there are also some interaction with the environmental factors. And the other theory, it's not only genetic, but it's also reflecting the loss of capacity of our cells to react due to cross-linking of proteins in DNA, mutations in DNA, mitochondrial lesions. So all of these, poor use of oxygen, oxidative stress, poor DNA repair, telomere shortening, this is replicative senescence. It's the second theory. It's more related to the activity of the cells than to the DNA basis of the individual. Okay? What is? Good question. We'll see that immediately after. Fragile syndrome is a syndrome that is associated with aging. And what does this mean? It means this. This is the accumulation of alterations, physiological alterations that increase with the aging of the individual. And this is reflected not only in the brain, but at several levels of our organism. So, a part of the brain, senile dementia, balding, right? Losing hair, deafness, cataracts, loss of teeth, dermal elastosis, which you will see that it's those wrinkling of the skin, hypertension, ischemic disease, diverticular colon, prostatic hyperplasia in men, degenerative joint diseases, and edema. All this is part of what is called that frailty syndrome. So frailty means that people are more susceptible to external damage. So they are less able to recover, and they are more easy lesioned, right? And if we see about the skin, so this is the norm. Hello? Now this one stopped communicating. Okay. So this is our normal skin, and this the skin of an elderly person with those ruga, you know. And why is this? Because in our skin we have several proteins that give elasticity to the skin. It's this fibrillin, elastin, collagen, and we also have adipose tissue. Everybody has adipose tissue, subcutaneous adipose tissue that is lost with the aging. And if you have something that is in your cell, in your skin, making it flexible, if you lose that, will support, let's say, the skin like falls, you know, and then it loses elasticity because the elastic proteins, the ones that allow our skin to stretch, are lost with aging, right? So this is the same thing. You see here masses of collagen accumulation, abnormal accumulation of collagen in an old person. Another very common change is in the level of bones. You probably all heard about osteoporosis, which is basically related with calcium metabolism. And calcium metabolism is deregulated with aging of the persons. Okay, so what happens? This is the normal bone. Okay, this is the look of a bone if you cut it on the microscope. And what happens? It's a reduction of the bone mass and the reduction of mineral deposits, causing the bone to be much more thin and fragile. Again, frailty syndrome. And another thing is the degeneration of the joint. Okay, so we have also lower aggregation of cartilage. You know what is cartilage? Lower aggregation of the cartilage, lower hydration of the matrix of the cartilage, and the cartilage that recovers the bone sometimes even disappears, or it has calcium deposits. So this one is still thinking. Change. To osteoporosis. We are talking about dementia. There is not a quite complete answer, but the hypothesis is related with the presence of testosterone in men. Testosterone is a hormone, male hormone, that has it also wastes more the men than the women. That's why the expectancy of life of men is lower than the expectancy of life of women. But it a little bit, that's an hypothesis, as I'm telling you, it protects from neurodegeneration. So it's basically a hormonal factor. Okay? So, and about osteoporosis, what happens is that this is a very balanced metabolism. So we eat and we absorb calcium. That calcium is absorbed in the intestine and it goes to the bones to mineralize the bones. And when we need that calcium, we reabsorb it and we use it. And then it is eliminated, the excess is eliminated by the kidney. So if these processes get corrupted, what happens is that we eliminate more than we deposit. And then the bone gets without calcium and gets the mineralization disappears. So this is you will soon be able to see the differences of mineralization in the bone matrix. So I think I have to change this while I'm still talking to see it at the same time as me. Okay, so this is a normal bone, right? And this is osteoporotic bone. So you see, these are the bone minerals on a normal bone, and here is osteoporosis. And there is a normal bone seen in microscopic amplification, and here is all these spaces, these rod-like spaces that lead to a much more fragile bone than the normal bone. Also, regarding the joints, the elder have several problems of the joints, not only the joints themselves, but the intervertebrate disc of the spinal. Do you know what that is? It's those discs in between the vertebrae that are present here. And in the elderly, we have several problems, even herniation of the inside of the bone marrow here, or we can have the calcification of these discs, and then they lose their, or they even have some cysts. So that gives problems in our spine and the curvature that some people get. And here you see another cyst of a joint, in this case of a femur bone. So in here, what you see is that the normal cartilage was replaced by a little bit of calcium deposits. What about muscles? Do you think muscles are the same in the old and the young? Young are stronger than older, huh? Right? You run faster. Sure. And why? Because the ability of the proteins to rearrange in the muscles are lost in the old. So the proteostasis is lost, and as a result, the proteins are not recycled, the contractile proteins, and the muscles lose their mass. So this is a normal young adult microscopic site of the proteins. This is the normal muscle, and this is the age muscle with this histological degeneration. It seems this stopped working. Probably without battery, I don't know. Yeah, I will say, don't worry. So another change is in the vessels. There are cardiovascular changes in the age. One of the biggest changes is, do you know, the layers of artery, intima, media, and adventitia? So there is a thickening with aging, a thickening of the inner layer of the vessels in general, okay? And there is a fibrosis of the tissues that support the vessels. All the vessels have muscles to contract and distend because of variations of blood flow, okay? And if you lose that tissue, the ability of the vessels to distend or to relax and to contract is lost, okay? And the diameter of the blood vessels is smaller. That is called arteriosclerosis. So this is one of the consequences of aging. And the other is this doesn't change. Okay, now it worked. I was using that. Okay, doesn't matter. So another thing is the accumulation of lipidic plaques in some parts of the arteries. That's what you see eventually here. So this is a plaque, and this is what we call atheroma. So this is atherosclerosis. So there are two things. Arteriosclerosis is the general lose of flexibility, and atherosclerosis is a local deposition of a plaque inside the artery that blocks the artery or the capillary, okay? And what about the heart? The heart is the same. So we lose also the ventricular function of the heart. So the heart also gets altered. So the left ventricle gets more thick, and with fibrosis, there is a reduction of the function of the heart. So in the result, the cardiac output in the elder is lower. So now you will see the differences in the tissue of the heart. This is the normal tissue, and this here is the age tissue. So it's much more irregular. And this is the heart of an aged person. See here the ventricular space, and here the ventricular spaces. It's much lower. So the ability of the heart to expel the blood is much lower in the elder than in the young. So last part I will talk, it's just 2 more slides for you to go to sleep in another place. So another consequence of aging is what we call immunosenescence. And in brief, is the loss of ability of the immune system to respond to diseases. And everybody heard about this very recently, right? So what happens in the immune system of elder people? They are not able to respond to, for example, vaccines, because they don't have the cells that are able to react to new stimuli. They lose the naive T cells because the thymus stops work and they can't produce new cells to new factors. Okay, so they have the memory cells for the old exposure to diseases, but they have really very much trouble to respond to new diseases that appear that they never contacted before. That's why they are much more susceptible to new appearing pathogens, like which one appeared now? Like COVID, exactly. And that's why those populations are much more susceptible and they died more, unfortunately, as you know, due to COVID infections than the young people, right? So this is basically all. Sorry for this disturbance of the slides. Yes, go on. Microglia also, yes. All microglia is specific from the brain, but also T cells from circulating body, and the B cells are much less responsive than the cells from the younger person. Okay. Any more questions? Aging again? Muscles, yes. No, there are two different concepts. Working out and producing exercise to increase muscle mass, the benefit for the aging is not the muscle mass, is the exercise, because the exercising burns radicals, burns as a consequence, you have a bigger muscle mass. So it's not the muscles that protect you, it's what you do to develop the muscles that protects you. Okay? More questions? Is go there. Any more questions? It's a nice. Do you think I need to sit now? Yes. Yeah, so it's a nice presentation, and a lot of questions can be raised on these issues. What should be the common minimum denominator which can cause, because whatever is happening, be it metabolic, be it hormonal changes, be it any other. So is there any common minimum factor or molecule, anything we know of as of now? Hello. Common factor for aging or for neurodegeneration? For aging, well, I will bet not only one, but reducing the number of reactive oxygen species, because there is also a theory that the aging is related with exposure. Aging always occurs. That's a factor. There is none we can do to avoid aging, unfortunately. But maybe it's better if you have healthy food, if you have make exercise, and if, because as I told you before, that increases your defenses, it stops accumulation of toxic metabolites or catabolites in your organism and reduces the number of reactive oxygen species. Actually, with your diet, you are not too bad, because you eat lots of vegetables and green vegetables, and also fruits are also good to protect it. So I don't know if I answer your question. Yeah. There cannot be one answer. I do understand. One thing I noticed that you didn't talk about autophagy. No, that is one aspect. Since there is no other question, I thought that there has to be some discussion here. Otherwise, the scientific talk doesn't look like that.
One of the factors that I can say, like for example, the amyloid beta plaque, that does have their aggregation has something to do with the pH. For example, if we had done with amyloid beta 1 to 40 molecule with noradrenergic, the CD spectra does change to give their molecular the aggregation effect. We were interested in, because whatever little I have worked on, that is with REM sleep. And the sleep is one of the factors for any of these things where it gets. So I was interested with noradrenaline. And it so that it does affect with higher noradrenaline level, which happens during during REM sleep loss. It could affect the aggregation of amyloid beta. And if it does so, it will change. But my question here is, even be it amyloid beta or the fibrils, why does it kill the cell?
Amyloid beta doesn't kill the cells. Amyloid beta is extracellular.
But it does accumulate inside as well.
No, that's neurofibrillary tangles. That's tau. That's another protein. Tau accumulates inside the cells, and that one kills the cells. And it's true. It's true to the loss of autophagic elimination of aggregates, and that's common to these misfolded protein diseases, because the misfolded proteins are normal proteolytic degraded, and when proteolysis from ubiquitin, for example, doesn't work, they follow the autophagic elimination, microautophagic or chaperone-mediated autophagy, and when the proteins are too much, let's say for the cells to deal with, they start to accumulate inside the cells in lysosomal vacuoles that are not degraded. And those vacuoles, when they blow, they destroy also the proteins from the cell, and the neurons die. And there are two things that can happen. If they die if the level of autophagy is not too high, the cells can die by a mechanism of apoptosis, right? Or if the aggression is too big, they die by necrosis, which is the worst that can happen. Because if they die by autophagy, it's a silent death. There is no secondary effects. The cell just disappears. If they die by necrosis, due to the loss of autophagic function, the cell leaks their internal content to the extracellular media, and the proteins that are degrading the cell inside can also degrade the tissue around due to an inflammatory response, and that's not good. That fortunately, it doesn't happen much in neurodegeneration. It's more apoptosis than necrosis. But the problem is that the aggregation inside the cell the cell doesn't cope with that much protein inside. Okay, and that's why the cells die. Okay, now talking about A beta, that's actually a very curious thing to talk, if you want to know, because I don't know if you know about the studies of antibodies. There was a clinical study 2 or 3 years ago, more or less before COVID, maybe, with the use of an antibody with Alzheimer diseases persons that removes the aggregates of beta amyloid from the brain. So people took that medicine, and the alpha amyloid disappeared from the brain. The problem is that they had many other secondary effects, and they didn't. If you compare then the placebo group, you know what is placebo group, right? If you compare the placebo group with the treated group, the difference in dementia or in dementia factors is not significant. So what does this mean? That maybe amyloid plaques are not the cause, they are a consequence. And if we eliminate the consequence, the causes are still there. Okay?
So I think the discussion can keep on going, and I thank Dr. Silva for this. And I will be happy if I invite you to my department. There are many colleagues and the students. just next door. So if you have some time, I might be happy to
Yes.
welcome you to the department, and we can continue the discussion further. Yeah.
Okay, and I'm not an expert on sleep disorders, far from me, but I know that that is actually very important, because if you don't sleep, a part of all the defense mechanisms that you lose one very important thing, which is, I don't know, you probably know that better than me. When you sleep, and if you sleep peacefully, what is that's REM sleep, it's the deep sleep. If you sleep well, the hydration of your cartilage is done while you sleep. So during the day, when you are walking and running, all the discs for intervertebrate discs have water, and that water is what gives them flexibility. And you are compressing them each time you are using a joint, and that water lowers a little bit inside. You recover that water when you sleep. So if you sleep bad, you have less possibilities of recovery your normal function of the cartilage and joints. Okay? So,
Okay, thank you, sir, for such an insightful lecture. Now, I will request Professor B.N. Malik, sir, to present a small memento to Professor Rui Silva on behalf of Amity Fraternity.
It's my pleasure to listen to Professor Rui Silva, and thank you very much for the talk. And it was my pleasure to be here. Thank you very much for the So it's for me to open, right? I have the same problem in Christmas presents. I will just destroy those. Your names. Yeah. Oh. Very, very good. Very nice. Thank you very much. Sure.
So now, on behalf of Amity, I want to propose a vote of thanks. On behalf of our respected Honorable Founder President, Dr. Ashok K. Chauhan sir, and all the Amity fraternity, I extend heartful gratitude to Professor Rui Silva for gracing us with his insightful lecture. Your expertise and global perspective have enriched our understanding and broadened our horizons. We are immensely grateful for your time, knowledge, and dedication in sharing your valuable insights. Thank you, sir. Your presence has not only inspired our students but has also strengthened our commitment to fostering international collaboration and learning. And we look forward to future opportunities to engage with you further. So, thank you again once for your enlightening contribution. And last but not the least, I would like to thank all the faculties and students of the Amity Institute of Neurosciences and to the IT team for their support. Thank you, everyone. Thank you.